Okay, I'm on 241, I'm kind of in the middle, and now we're gonna get started. So we looked at everything in GeoGebra, like how is this happening? And now let's see if we can do some of the calculations, come up with some generalizations, and just kind of like go from there. So first thing, let's consider the region in the first quadrant, bounded by the coordinate axes, the line x equals 4 and the curve y equals x squared. The region is shown below. That's a really common thing. You'll just be given the region because the descriptions are kind of hard to work out. Also, people have a lot of trouble with the notion of being bounded above. So this region is bounded above by y equals x squared. It's like it's the ceiling of the region, and it's bounded below by the x-axis because it's the floor. So the floor is what bounds you below. The ceiling is what bounds you above. It's just terminology, but people struggle. So what we want to do is find an approximation of the volume of the solid form when this thing is rotated. So we kind of almost looked at what this looks like in the last video. It's going to look kind of like what? A horn, maybe? I don't know, something. So first, let's use two cylinders to do this. So we're going to use two cylinders, and what we'll do, we might as well divide it up evenly, right? So I'm going to make my first cylinder go from 0 to 2. And then after I get to 2, because I'm going to use the right endpoint. So there's multiple ways of doing this. You can use a midpoint. You can use a left endpoint. We're going to focus on the right endpoint for this entire year. Once I get to the right endpoint, I'm going to go up. That's going to be the radius of the cylinder, right? Because that's what's going to get revolved because we're going around the x-axis. And so I'll go across. So this rectangle is what's going to give us our first cylinder. And then we'll do it again. We'll start here, we'll go over. And once I get here, the right endpoint is 4. I'm going to go up. That's going to be the radius of the cylinder because we're going around the x-axis. So there you can see the radius is going to be 16, which is f of 4. And we'll generalize that a little better in a second. Like this. That is our second cylinder. So our first cylinder is this one, and our second cylinder is this one. Okay, so let's see if we can do this. So the height for each of these cylinders is actually the same. They're both 2. So should I keep trying to do this in color? Probably. All right, so the height is 2. And then you should have this right in front of you because you're writing it down. The radius of the first cylinder is f of 2, which is 4. And so the volume is pi r squared h. So that's pi 16, 32 pi. Okay, so 32 pi, that's my first cylinder. So if I rotate this green rectangle around, I'm going to get a volume of 32 pi. That's part of the volume of the whole thing, but it's not the whole volume because now I need to do the second one, right? So the same height of the cylinder. So remember, the cylinders are kind of like they're laying on their heights. So it's going to have the same height of 2. That's actually a property of these. They're always going to have the same height because it just makes your life easier. The radius, though, is determined at 4. So we're going to find f of 4, right? It's 16, but it's really f of 4. And so I'm going to write that here. It's f of 4, which is 16. And so the volume is going to be pi times the radius squared times 2, pi r squared h. So radius squared is 256, so 512 pi. Okay, so what's our approximation of the volume of the solid? Well, it's going to be 32 pi plus 51 pi, 512. So it's going to be 544 pi. 544 pi. Is that a good estimate? Not really. I mean, take a look at all this overage. Let me shade it. We're over by not just this area, but it's Rotated, so it picks up volume. Volume is huge. The farther you are from the axis, the more volume you're picking up. So you're picking up a ton of extra volume here. It's not right, but we know it's an overestimate, and that's a good thing. So how could we make our estimate more accurate? Well, I mean, maybe it's obvious, and this will be the answer for like tons of questions going forward. How do we make something better? We do more of it. So how could we make it more accurate? More cylinders. Okay, so if we're going to do more cylinders, we kind of want to start thinking sort of generally, right? So for each of these, as I look at it, let me switch up. I'm going to say that this distance was a delta x, and then this distance was also delta x, and delta x in this case was just 4 minus 0 divided by 2. It's the total width along the x-axis divided by how many we're going to do. So we did 2. So in that case, we got 2. If we had done 10 slices, it would have been 4 minus 0 divided by 10, because they're all going to have the same height. And then the radius that we're finding is always going to be at the right endpoint. So that's why we first found it at 2, and then we next found it at 4. So it's always going to be the right endpoint. So these are big ideas. I'm going to cut this video here and come back on the next page and do a lot more, and probably also use the calculator a little bit. So get excited, get ready, get your calculator. All right, see you soon.